Okay, question number 7. We're given a name for the nth term of the sequence, un. And we're given a formula for it. It's 95 to the power of 4/5 n, where n is 1, 2, 3, 4, etc. Now, what's the value of u1? That's just this. What's u2? That times by 16, you just double 4 times, so it's 38, 76, 152, 304. I think. Yep. Okay, so that's part A done. We just had to find the first and the second terms. Now it wants the 21st term to 3 significant figures. Now I'm not using, by the way, any of this machinery. I'm just using a formula that they gave me, which is this formula. Okay. Now I think this is a geometric progression, but we'll come to that in a second. At the moment I don't have to worry about that. I'm just using the formula that I have been given. So 95 times bracket fraction 4, 5, 0.876 to 3 significant figures. Now it wants a sum. It wants a sum of these things we've been working out. Remember, sigma is just a whole bunch of things connected by plus symbols. What are the things that are connected by plus symbols? It's just whatever you get when you put a 1 there first, a 15 there last, and counting up in between. So put a 1 there, that's the first thing. Put a 2 there, that's the second thing. Put a 3 there, that's the third thing. And finally, put a 15 there. Now, a minute ago, I mentioned that I didn't know whether this was a geometric series or not. But now, and I was just happy to use the formula to work out the terms. But if I'm going to add them up efficiently, I just use a formula. So hopefully it's one of these two types of progression, because then I can use one of these formulas for adding things up. Now, is it a geometric progression? I'm pretty sure it is, because the first term divided by the second term, so the second term divided by the first term is 4/5. 95 divided by 1, 4/5 squared divided by 4/5 is 4/5 to the power of 1. That's just subtracting the powers. So that would be that's 4/5. And same again. If you do the third term, so I'm just going to write out the sequence. 95 times 4/5, then 95 times 4/5 squared, then 95 times 4/5 cubed. It's pretty clear it must be geometric, because that divided by that is 4/5, that divided by that is 4/5, and so on. Now I have to be careful here. The R is whatever you get when you go that divided by that, which is 4/5. But the A is not 95, it's 95 times 4/5. In other words, it's 76, it's the first term. Okay? Now, that means that we do need to be careful about using one of these adding up formulas. So, what have we got? We'll use this. We're going to add up 15 terms. It's pretty clear there's 15 terms there because it just counts 1 to 15. The first term is 76. The ratio is 4/5. The number of terms is 15. There's the minus 1. There's the 4/5 minus 1. And you type that through a calculator, and you get, I'm just going to look this up to save time. Get 367. Okay, and now finally, part D, 7D. It wants the sum to infinity of the series whose first term is u1 and whose nth term is un. That seems a bit confusing, but I think it just wants this. So this is a geometric series. So we've got 76 plus the second term, which was 304 over 5, etc., etc., etc. We're going on that forever. So the sum to infinity will be given by a formula. That's the A. Our A was 76, and our common ratio was 4/5. So that's 76 divided by 1/5, which is 76 times 5, which is 380. Question 8. Okay, so we've got this sequence of numbers. We've got a formula for it. Where n is a positive integer, etc. We've got to find, part A is to find the values of u1, which is 3 times 2/3, which is 2 minus 1, so that's 1. Second term is, this is now 4 over 3 minus 1, which is 3 over 3, so that's a third. And the third term is, what is it? It's 3 times 2 to the power of 2/3 to the power of 3 minus 1, which is 3 times 8 over 27, which is 8 over 9 minus 1, which is 8 over 9 minus 9 over 9, which is negative 9. Okay, so that's part A, to find the values of u1, u2 and u3. Just keep this neat. This is the sequence so far. Now we're going to show that when you add that up between the first and the 15th terms, remember this is just, sigma is just a whole bunch of things with plus signs in between. What is it that have plus signs in between? This expression with a 1 put in, then a 2 put in, then a 3 put in, and finally a 15 put in. So, can I use a formula for working this out? See, the problem is that is not geometric. That divided by that is a third, whereas that divided by that is negative a third. For it to be a geometric sequence, they need to be equal to each other. So I'm in a bit of a tight spot here. I'm just going to do Dear Mr. Examiner. I'm going to work out the fourth term, just because I can. The fourth term would be 3 times 2 over 3 to the power of 4 minus 1, which is 3 times 16 over 81 minus 1, which is 16 over 27 minus 27 over 27, that's the one, which is, what is it? Negative 11 over 27. Okay, so this is definitely not a geometric series. So how on earth am I going to add it up? Okay, well, let's just come back to our original set of categories. It's not a geometric, it's clearly not an arithmetic, because that minus that is not the same as that minus that. I really hope it's not genuinely miscellaneous, because then I'll have to work out 15 terms and just add them up with 14 plus symbols. So is it a one that is almost an arithmetic or almost a geometric, or a mixture of both? Now, all of these terms have the same thing being taken off each time. So, however many terms there are, they're all always that many less than if it had just been these. So, for example, if I added these up, the answer would be 3 less than if I just added these up. Now, do I have a way of adding these up? Actually, I do, because they're geometric. So, if I want to work out the sum of 15 of these, I create my own sequence, which I'll call Tn. Tn is just 3 times 2/3 the n. The terms of that sequence is this. It's put a 1 there, you get 2. Put a 2 there, you get 4 over 3. Put a 3 there, you get 8 over 9. Put a 4 there, you get 16 over 27. And this is geometric because that divided by that is 2/3, that divided by that is 2/3, that divided by that is 2/3. So this is a classic example of a sequence that's almost a geometric. It would have been geometric, but we kept on taking the number 1 off every time. Okay, so let's add up this. This is my own sequence that I'm doing here, not the one they have asked for. So it's 2 plus 4/3 plus 8 over 9 plus, and we want the 15th. That's when that is a 15. So we decided that was geometric. A was 2. R equals, that divided by that is 2/3. And the N is 15. So 15, in other words, the sum to the 15th term of that is 2 times 2/3 to the power of 15 minus 1 over 2/3 minus 1. You type that into a calculator, you get you get 16.014 to 4 significant figures. But what we really want is the sum of all the terms that were 1 less than those. If there's 15 and they're all 1 less than that. Oh, sorry, I made a mistake there. So it's not 16, it's 6. You take 15 away from that, you get negative 0.14 to 4 significant figures, which is what they wanted me to show. So, question 8 was a very tricky question where the sequence we were given did not fit into the chapter straightforwardly. We had to adjust it by creating a new sequence which was lacking those subtraction of 1s. We add that sequence up, get 6, take away 15, and get negative 9.014. Now, part C is to prove that un plus 1 equals 2 times 2/3 to the power of n minus 1. Okay, well, we had the fact that un equals that. And we have to prove, so this is a fact from the start, and we have to prove this. And how would I do that? Okay, the key is to remember that this thing here can be anything as long as it matches. If I want to write m there, it's fine as long as I put an m there. If I want to write 2k plus 1 there, it's fine as long as I put a 2k plus 1. So in this fact, I can write it like this. Because remember, algebra is supposed to stand for all possible examples at the same time. There's nothing special about n. It can become anything you like. Normally it would become a number, as we did before. Here it can become an alternative expression. Now, that is equal to 2/3 to the power of n times 2/3 to the power of 1, because that would cause you to add the powers, which is 3 times 2/3, which is 2. Which is what we wanted to show. So that's now done.